Hello everyone, today I'll be presenting an astronomy problem of the day about the TRAPPIST system. And the TRAPPIST-1 system contains 7 planets, some of which are in the habitable zone of the star. And this star is smaller and cooler than our own. How is the temperature of these planets going to be expected to compare to the temperature of planets that are in the habitable zone of our own solar system? And the second part of this question, which is quantitative, says that if the luminosity of the TRAPPIST-1 system is 0.000522 times the luminosity of our Sun, and the planet TRAPPIST-1b is 1.65 times 10 to the 9 meters away from the star, how does the brightness of TRAPPIST-1 at the surface of TRAPPIST-1b compare to the brightness of the Sun at Earth? And it also gives us numbers about the luminosity of the Sun and the distance from Earth to the Sun. To tackle the first part of this question, we have to discuss the nature of the habitable zone. The habitable zone for a star is merely the area where we believe there is enough light for liquid water to exist, but not so much light that it would boil away. So for different stars, the habitable zone is different distances and different sizes. However, the temperatures in the habitable zone will always be the same. And this means that for any planet in the habitable zone, it'll always have roughly the same temperature. After all, just because the star is cooler doesn't mean water will fundamentally change how it freezes. So the answer to the first part of this question is that we can expect them to be we can expect the planets in the habitable zone to be about the same temperature as Earth, since water will always freeze and boil at around the same temperatures. To tackle part B, we first need to write a formula for the brightness of the Sun at Earth, which is the luminosity of the Sun divided by 4 pi times 1.496 times 10 to the 10th meters squared. And this is because of the inverse square law, since the brightness of an object expands with distance in a spherical net shape. And then we need to know the brightness of TRAPPIST-1 at TRAPPIST-1b. And so we have a multiplier that was given to us for the luminosity of TRAPPIST, and we have the distance TRAPPIST-1b is from TRAPPIST-1. And so then we can establish a ratio, and we divide the brightness of TRAPPIST-1 at TRAPPIST-1b by the brightness of the Sun at Earth, because we want how many times the brightness of Earth, the brightness of TRAPPIST-1b will have. The temperature. So first we can cancel the luminosities of the Sun, and then we can cancel the 4 pi's, and what we're left with is the multiplier of the brightness of TRAPPIST times the distance from Earth to the Sun squared divided by the distance from TRAPPIST-1b to TRAPPIST-1 squared. And calculating this out, we get a value of about 4.3. And what this means is that the temperature on TRAPPIST-1b will be about 4.3 times the temperature on Earth. So it is definitely not hospitable. Thank you for watching.